Excellent. Th Thank you, Ali. I'm really excited to be here. And just before I start, I want to thank Ali again and thank everyone from JNIPER and everyone joining because this is really exciting for me to get to share these projects with you and ask people for feedback. Uh, I've only missed one Juniper coffee hour yet because I've found them really excellent. So thanks for running all of them as well. And the only one I missed, it was because rather than having coffee, I was having wine with people at CERN and meeting people in person. Like it seemed worth missing that one. So I'm really excited to get to present this and to get feedback from some of the best people in informal physics education in the world. So I'm going to start off with just explaining a little bit who I am because I'm kind of an atypical candidate or atypical person for this. So my background is science teaching, both physics when I was teaching older kids, but all the way down to like 6-year-olds with gifted programming. I've been heavily involved in teacher networks, especially in Europe. I'm the French ambassador for Europe's two biggest networks of science teachers, Science on Stage and Scientix. As Ali mentioned just before this call, I got back from Kazakhstan where I was at their Science on Stage festival, both performing on stage and judging teacher projects there. But then specifically why I'm here, presenting something about informal physics education. I'm starting a PhD in particle physics outreach and education. And I'll talk about some of the projects involved with that, and especially a particle physics for teachers course. And that's the main thing I'm presenting, looking for feedback and expertise, how to make it better before I start it 2 months from now down the road. So one of the interesting projects to explain like my background first is science performance. So a year ago, I left the classroom to teach myself how to perform science shows on stage. And I came up with my first science show I called Experiments World Tour, which was a sampling of different experiments I learned from meeting teachers, educators, professors, museum people around the world. And this new show I'm developing on particle physics, it's one that's being developed in collaboration with CERN Science Gateway. So if anyone's not familiar, CERN is opening a brand new public outreach or public welcome center, Science Gateway. Amongst other things, one of the things they're doing is science shows for performances when visitors come to CERN. But of course, they're not portable. What they design is feasible at their facilities. And so I'm designing a lightweight version of that in collaboration with Anya Horvat, she might be on this call if she gets here in time. But she's the manager of science shows there. And it's combining the two ideas of me looking for low-cost experiments, portable things to take on the road, either on a backpack, in an airplane, like I just got back today from somewhere around the world, to make it more accessible in different places where you don't have the facilities. So I just got back from Kazakhstan. Next week, I'm going to Serbia and then Montenegro with it. And then the next month, France, Bulgaria, and a number of others. But I've spent a lot of time planning things, but not necessarily dates. I'm not sure where I'll be for sure on it. But that's one of the background projects that I've on the go. The other one leads directly into particle physics for teachers. And it's a particle physics for kids course I developed originally during the pandemic. So 2020, when schools were closed down and we shifted to distance teaching, I was still a teacher at the time. Then I came up with what I called virtual science camps, which were an invitation for kids to do experiments around the home with things they could get either from the kitchen, from a grocery store. Depending where you were, some of us were down to like going to a grocery store once per week, every 2 weeks, because we were supposed to not mix with the population. So really simplifying the set of materials you could use. And one thing I loved about it was I was able to get kids from several different countries in each Zoom session, like on average from 5 different countries, sometimes from 10, maybe a little bit more at the maximum, but like not that many more than 10, because that's already a lot of different countries to have kids together on. And then once we were back in school, it was great to have kids in person, but I missed having an international group of kids join me every day. So I came up with ideas of making it worthwhile for people to continue. So I invited some of the most exciting guest hosts and continued with particle physics for kids. And with that, I had an alternating plan where I'd have one time a week with a guest scientist or someone doing some kind of outreach, like a professional, and then an experimental session, usually led by me, sometimes led by some of my students, which would support what was being done in the scientist session. So one example, I put some pictures on here. This was a science show led by Anya and Sarah at CERN's school lab. And it's their show called It's Just a Phase, which went over phase changes and their importance for particle physics. And then for the experimental session, I invited a student who he'd won a science video contest I had run for students a couple of years ago with an instant ice experiment. And I invited him to run part of the session to showcase that experiment. So getting both ends of the spectrum there, both scientists and students sharing with kids around the world. And it went well enough that with encouragement, I reran it the next year, so last year. That was largely thanks to Steve Goldfarb, who was one of the co-chairs of the International Particle Physics Outreach Group at the time. And I met him by chance when I was trying to get an Atlas virtual visit. And his reply was, I'd love to do a visit, but this is a cool project. Would you like to share it with iPod? And so the answer was, of course, I'd love to. And I got a lot more guest hosts and was able to keep up energy for the next season of it. But by the end of that, I noticed that more than half the participants were actually teachers looking for new ideas for their own teaching. So the next logical step was go all the way and make a dedicated course for teachers and have the focus be to give them ideas that they can use in class. But it takes a lot more planning and time. So here we are, late 2023, and now I'm just finally getting all the pieces together. And that's the main reason I'm here today, to ask for everyone's help and feedback. And if anyone wants to join as a guest host as well, I'm always looking for guest hosts. So transitioning into like the main part, particle physics for teachers. So a couple things I want to accomplish with it, both with this course and with my show and with other like things I'm doing as part of my PhD. The overall goal is to make particle physics more accessible to new audiences, whether it be general public, young kids, in classrooms where teachers don't yet have the excitement, curiosity, knowledge to include particle physics in non-particle physics part of the curriculum. And then another big one is bridging the gap between scientists, researchers, outreach people, and classroom practice. And I've noticed in the past couple of years, like once I started getting involved in particle physics outreach, I guess, that there's some people doing great work who complain that it's difficult to get teachers to pick up what they're doing. And part of that is there's often a disconnect between what goes on in the classroom or a teacher's reality and what goes on either in a research facility or in a museum, or like they're just different constraints. And so I try and have a perspective from both points of view. Like my main perspective is going to be from teaching, because I have a decade and a half of experience for that. But learning more about what's going on the other side of it, trying to make things more accessible. And then like smaller specific goals in the class are increasing knowledge, confidence, and interest amongst teachers in order to get more modern physics, more particle physics into the classroom. So that tentative schedule, and this is something I'm still finalizing. So if people have suggestions saying, oh, that's completely wrong, but the idea here is kind of zooming in from an overall, like this is an intro to particle physics, then looking at the path of a particle through an accelerator chain, through a detector, and like going on that way. And then leading off with where can you go from there, or how can you go further? And then in the new year, going into deep dives on specific topics that don't necessarily make sense to go into with like a relatively short course, because it's going to be a little bit limited how nerdy some teachers are, or how much they'll want to go into all of the details of, say, a subdetector. The subdetectors of a big detector. But once you get into the fine details, there's a lot of pretty standard, pretty basic science that goes down even as low as like middle school science, like grade 7, grade 8 science, on the motion of particles or magnetism, things like that, that you can bring in with examples from what's going on in a detector, even though, of course, to fully understand a detector, it's more complicated than that, which is why it's often skipped over for classroom practice. Just one of the examples of pairing it up, because I think I got nervous and forgot to mention this, but the plan is to do the same thing as particle physics for kids and alternate a scientist leading a session that could be a lecture on their research, a virtual visit, a science show, and then a pedagogical session that'll usually be run by me, sometimes by another teacher or like different friends I pull in. But the pedagogical sessions would either be classroom activities, linking to curriculum, or coming up with how things can actually be used in the class. So focusing on the Atlas experiment as one of the detector ones, then a good way to start would be a virtual visit. This is a photo from that famous virtual visit with Steve Goldfarb before he invited me to present for IPOG. And then for the pedagogical session, going over different resources that can be used, like Atlas schematics or the coloring booklet, and looking at how that fits within different parts of a science curriculum, different parts of a physics curriculum. So that being the idea of alternating between scientific and pedagogical session. The other thing that I am looking for a lot of feedback on, if people have input on this, is how to evaluate the course. A lot of you are probably aware, some of you probably attended, well, at least 2 of you led the JNIPER course at the end of June and beginning of July in evaluating informal programs, which was a gold mine for getting ideas for this. So big thank you again to Ali and Jessica. But there's more detail I need to go into how I'll evaluate this program. So getting back to different things that I'd want to evaluate, there's, of course, the goals, which I went over at the beginning, bridging the gap between researchers and teachers, getting teachers more interested, getting teachers more confident, getting ideas used in class. But there's also personal goals, both for me and for the guest hosts I'm trying to get to join. So for me, one of the personal goals, which, I mean, you could say is a hidden goal, but it's not that hidden because I'll speak about it frankly to anyone who's interested in listening. I'm also embarking on a learning journey where I'm trying to learn as much as I can about this topic, which is a reasonably complicated topic. And one of the best ways to learn is by learning from the best people in the world. So even though I'm structuring the course mainly to share things with other teachers, I'm also learning as I go as well. So that's one of my goals. And this is a course that I haven't found something that exists that I could just attend like that and learn as much as I'm learning by running it. So like that's a pretty cool goal. And then the personal goals of the people I'm getting to come on as guests. One of the things that people I've met and people I've had join have been, they're people who are eager to do outreach to get what they're doing out to more people. And so some of the metrics, which I'll mention next, work well for like an incentive for them to get their work out to more people. Going into detail about the metrics, the top 2 there are pretty easy to measure. So just by taking attendance, having a Google form when people sign up, I'll be able to have how many people sign up. I can look in a Zoom session, how many people attend, a number of countries people come from. And these are often like cool things to have numbers, but there's not necessarily that much meaning in terms of uptake by the teachers. So the last 3 are significantly more difficult ones. And I've got a couple of ideas on how to measure and address those metrics. But as I keep saying, like, one of the reasons I'm presenting is to get more ideas or have a better idea what I'm doing. So in terms of looking what's going on in a classroom, one of the things I've noticed running other programs is you don't necessarily need follow-up from all of the participants to know that ideas are being used in classes. Going back to my experience, like running workshops and professional development for teachers, one of the big things I focus on is low-cost experiments. And I'll often say, I would like you all to use these ideas in your classroom soon. And often I don't hear back from teachers. Sometimes like years later, I'll visit a school and a teacher will show me things and they'll say, oh, look at these things I did with students. And I'll have no idea. that anyone from that course had done anything. So I try and work in ways where teachers are encouraged to give feedback, sometimes with incentives like prizes or contests. One of the ones that was particularly successful from a webinar I ran, I was showing, amongst other things, how to make a microscope attachment with a cheap, like 10-cent collimating lens. And I said, okay, anyone who shows any of the experiments I've shown being done in a classroom within the next month, I'll mail you a class set of these lenses for free. And so I didn't hear back from everyone who attended the webinar, but I heard back from 3 of the most enthusiastic teachers. And one of them ended up actually being a board member for Science on Stage through his encouragement. Not only did he encourage me to keep doing particle physics for kids, and I might have lost energy at some point with that if it wasn't having people like that encouraging, but I wouldn't have become involved with Science on Stage, whereas now I'm heavily involved in that network of teachers, just from that method of getting feedback, getting evidence of whether my ideas were being used. So I've got a couple of tools like that in my arsenal. In terms of whether teacher knowledge increases, whether teacher confidence and curiosity, the easiest way is asking or having a survey or questionnaire. It's not a perfect way of measuring things. And certainly if there's a lot of questions, it's like we'll see at the end of this coffee hour. Ali has nicely asked everyone to fill out a feedback survey. I'm guessing after a lot of coffee hours, probably only half the people fill that out. Is that roughly correct, Ali? Or is this not a representative sample? Does everyone fill things out?
I'd say we're less than half. We're closer to a quarter, but it depends on the event.
Okay, see, and that's typical for trying to get feedback from a survey for anything. And so one of my tools I'm going to use is to incentivize the feedback, because a lot of teachers like certificates when they've done a course. And so if I incorporate quizzing them for knowledge as proof that they can get a certificate, I don't need it to be a big quiz. It can just take a couple of minutes, but the incentive of having a certificate, I'm hoping we'll get it not to 100% filling out the survey or filling out the grid survey. I need to figure out what I'm calling it, but using as many tricks as I can to try and get the response rate as high as possible. I'm looking, like I keep saying, one of the things I'm looking for is existing practice. Who's running similar courses? Who knows of what research is out there? Because as I mentioned in the beginning, this is one of many projects I'm putting together for a PhD thesis. And I could run an excellent course, but if I don't link it to existing research or contribute meaningful research, then it's no good for the thesis. And that's something that's completely new for me. I'm used to thinking I need to make successful programs that work. But in terms of research, I could make a terrible course as long as I write about it and it informs what you can do better for other courses. Hopefully I'll make an excellent course, but certainly research is new to me, so any feedback on that would be very welcome. One last project to mention where it would be great to get feedback as well. Unrelated to that, except that it's related to particle physics outreach. I'm writing a proposal for the International Particle Physics Outreach Group on their resource database. So hopefully everyone's aware and using their resource database. If not, hopefully my proposal will include some ideas to get it. So this time next year, everyone will be aware and using it frequently. So they're trying to make the world's best one-stop place to go for activities in particle physics education and outreach. And I'm trying to come up with a proposal on how to improve what they have, especially in the diffusion of it. So once it's, I lost my words there. But one of the things I'm looking at is how existing practice can be used to inform how this can be done better. So I've reached out to a number of places that I admire, that I consider the best places in the world for this, like the Perimeter Institute for Theoretical Physics, the Exploratorium in San Francisco, which their Teacher Institute has what I consider the best collection of, they call them science snacks, small science experiments you can do. CAFM, probably no one here knows that acronym. That's the Canada Agriculture and Farming Museum. And they have a great database of agricultural experiments. I was a teacher in residence there, so I don't just do particle physics, I do all kinds of science. And they're great people there. So they're one of the sources of inspiration. The problem with all of these ones and using them as a basis for research, they develop their own resources and their databases are primarily with in-house developed stuff, which is a completely different set of, a reasonably different set of constraints than having members of an organization or looking at things that aren't even created by members and just having things open to all resources that exist on a topic. So they're not, they can help inform aspects of how a database could be good and especially how it can be diffused. Like Perimeter is excellent for this. The workshops they run to get teachers using their resources, they're an excellent model to follow. But Scientix comes in as one where their database or their Scientix repository has resources contributed by a huge number of members. And so for the idea of managing something that comes from all sorts of different sources, it's perhaps a better one than that. But I'm desperately looking for existing research on what's being published on this kind of database. And I'm new to research and I've come up with a couple of things, but not all that much. So those are all the things that I wanted to share and things that I'm hoping people will discuss. So one final slide. Well, actually, there's one slide with my email address on it after this, but like one final slide with things that I'm hoping to get feedback on and hoping that we can discuss. So just to overview that the bulk of what I presented about and said I need help and ideas on is particle physics for teachers, both the structure, evaluation, research, and if people want to join as guest hosts, please, I'm always looking for more people. Then the IPOG resource database, if people have relevant research, it can point me in relevant experience or can point me in the direction of research. And also for particle detectors, I'm a lot more confident in that, so I don't need as much feedback. But if people have ideas, like if you thought, oh, that's great, this would work well if you do this as well, or if you want to invite me to perform anywhere, or once I deliver the script to CERN Science Gateway, which like that's the deliverable they're getting from me, the plan is for it to be published and anyone to freely be able to do it with instructions I'll be writing on how to put together the experiments for it as well. So even if you don't want to invite me to perform, hopefully a couple months from now, you'll be able to put it together yourself based on the documents I'm preparing. So it's everything I'd like people to discuss. Hopefully people have ideas they want to share and discuss about this. So thank you for listening and thank you in advance for any ideas you have to contribute. Oh, and here's my email address in case you think of anything after the discussions.